Hey, good morning, and welcome to the webinar today. My name is David Pote, and I'm with Amazon Web Services. And today we're coming together with our friends at Informatica and our friends at HBX, which is the Harvard Business School. And we're going to learn all about how their digital education went data-centric using Redshift and Informatica. So long title, but there's some good stuff in here. So today's presenters, me, David Potes. We'll also have Andrew McIntyre from Informatica and Ryan Fraser from HBX. So we're going to take a look at AWS and AWS Marketplace. I'm going to talk a little bit about our big data solutions with a special focus on Amazon Redshift, our enterprise data warehouse, and Informatica is going to go through the solution overview, so how they can use Informatica to connect things up, and then how HBX did it. And then we'll have some time for Q&A and discussion. And I'm going to answer the number one question right now. Yes, you will get a copy of the slide deck after the broadcast. So stick around for Q&A at the end of the presentation, and we'll try to answer all of your questions. And what do we want to get out of this? Well, we want to understand how becoming data-centric really helps juice up your business results, and how using agile analytics with a cloud data warehouse really can pay off, and how to integrate the high volume and really disparate data into a fully trusted source so that you can make those decisions. So Redshift, in one sentence, fast, simple, it's petabyte scale, and you can get started for as little as $1,000 a terabyte per year. And it comes packed with features. I think we're clocking 140 plus at this point, with plenty more innovation on the way. And how does Redshift kind of fit into our big data portfolio? Well, we put things in kind of three broad categories. At kind of the ingest stage, we do collection, and you can do that through Kinesis for real-time data streaming. We have tools like Snowball that allows you to get big chunks of data up into the cloud, and things like Direct Connect that allow you to connect your existing on-premises network directly to the AWS cloud. So once we collect it, kind of the next step is, where do we store this thing? And you have a couple of choices. S3, it's a great choice. It's extremely durable, and it's very, very cost effective. Dynamo for single millisecond latency on a key value store database, or traditional relational databases like RDS or Amazon Aurora. We have Cloud Search and Elasticsearch. Lots of ways to store things. And what do you do next when you're ready to analyze that? Well, kind of in the center there with the box is one of my favorite services, Amazon Redshift. And I say service, we're going to talk about that in just a little bit. But do know that we have tools like QuickSight for visualization, machine learning, and just recently announced at reInvent Amazon Athena, which basically allows you to do SQL queries against data stored in S3. When we look at kind of legacy data warehouse models, because kind of the old model of data warehousing was very expensive, the licensing could be very inflexible. You'd have to do a lot of planning, 1, 2, 3 years out in terms of licensing. You're often locked into proprietary platforms, which made it hard to keep up with the explosion of data that we've seen. And if you look at that chart, we're looking at a little bit of a hockey stick around 2010. We did see, the volumes that come in continue to increase, whereas kind of the legacy models to keep up with that, they're not keeping up. So what we end up with is dark data, which is data that you're generating, but you're not extracting value from. So traditional data warehousing, is one of the kind of use cases that we talk about with Redshift. So, the kind of the output that you think of is very similar, but, we kind of take an AWS take on that, and we give the ability to do very, very easy migration. So point and click using the migration service. It's secure end-to-end, and we have a very large ecosystem of tools that kind of plug into the Redshift infrastructure. And don't take it from me, if you look at what NASDAQ has done, they ingest over 5 billion rows a day per trading day. And they have to analyze the orders and trade in quotes to protect traders, and then they have to report on that activity, and they're able to do all of that in Redshift. It's an interesting case with NTT Docomo. They're using Redshift as their primary analytics platform, and this is a massive multi-petabyte data warehouse on Redshift, which they can use as their primary analytics platform. Another great use case we see for Redshift is log analysis. This machine-generated data, application data, time series data. It just seems like there's more, and Redshift is really well placed to keep up with that growth because it's a fully managed service and it's built for scale and speed. So, a couple of customers that are doing cool things with it. You may have heard of Yelp, Lyft, or Pinterest. I certainly have. These are all massive log analysis jobs that they're doing within Redshift. And of course, business applications. Without keeping the business folks happy, we're probably all out of a job. And one of the things that makes it really easy here is because it's fully managed. A lot of that work is built in. So really, you can focus on running your business apps and serving your customers. And because it's pay as you go, it's really easy to do a chargeback model if that's the approach that you're looking for. And we've got a couple of big customers and partners here that are using this in this model, but I can tell you that this is a very common approach to using Redshift. And it's not just for side work either. Companies are using Redshift for their absolutely mission critical workloads. This approach really goes to the heart of the things that they're trying to do. So, for example, FINRA, their job is to manage the financial markets, and they have to do an incredible amount of analysis to find very sophisticated attempts at fraud, and they do that in Redshift. And what's great about Redshift too is that as you know, there's a number of regions that AWS has opened, and in the last few years to go along with our existing ones. And Redshift is everywhere except for Montreal and London, and that's coming very, very soon. So no worries about having to send data halfway across the world. We're where you are. And it's fast. There's some quotes here from the customers about just some of the amazing, ridiculously fast things that they're seeing from Redshift. And don't take it from me. I mean, take it from them. And I can tell you a little bit about why it's fast and it's gotten faster. So just in the past year, with some of these new features that are listed here, we've seen a 5x query throughput improvement. And a 10x vacuuming performance improvement. So the vacuuming is really key to making sure that your data is sorted for that really efficient I/O, and it cleans up space from deleted rows. And kind of overall, this really leads to a much faster throughput for the system. And it's easy to use. I talked about this a little earlier, but the fact that it's a fully managed service kind of gets you out of the business of having to turn all the knobs and pull all the levers to be able to get the performance that you want out of the system. It's ready to go when you are, and you can get started in just a few clicks. It's easy to use. I mentioned that it is fully managed, but you really can get up in just a few minutes. It's automatically patched, backups are built in, and security for us is job zero, so it's built in right to the core all the way through the product. And compression is built in as well. And Redshift does a good job of choosing the right compression based on the data that you're putting in there. So it's got a number of different ways that it can approach that. It's cheap. I'm supposed to say frugal, I think, but Redshift is cheap. I mentioned that you can get started for about $1,000 a terabyte per year. What we see from customers is that the cost of running things in Redshift is a fraction of what they were paying for on their on-premises data warehouses. Kik, I think, was one of the cool ones. They actually knocked 90% off their costs. They went from $1 million a year to $100,000 a year, and this is how you get promoted. So it's very durable and available, right? We want it to be something that you can absolutely count on. But things happen, right? So you put the systems in to make sure that you're highly available and you're highly durable when something goes wrong. So cross-region backups, I think, is a big one. You can do mirroring across clusters, streaming restores, so you can shorten your mean time to resolution and great monitoring tools and ticketing tools to keep you up and running. And it's secure. I mentioned that security is job zero, and we take that incredibly seriously. So end-to-end data encryption, you can use our HSM, our cloud HSM for additional key security and KMS. Everything's audited, and we have a number of certifications and compliance regimes that we're certified under. So what's available now? There's some pretty cool features here that have come out in the past, 6 to 8 months, and there's some really cool stuff coming soon. One of the ones that I'm most excited about is IAM authentication for DB users, as well as faster ingestion of JSON and Avro format data. So I'd like to hand it over to Andrew McIntyre, and he's going to talk about how Informatica works so well together with AWS. So Andrew, you want to take it away?
Yeah, thanks, David. So now that we've heard from David on AWS services and the Amazon Redshift connector specifically, let's talk about how Informatica and AWS together can support you in building out your analytics environment. So within the past 10 years, there's been a dramatic shift in the marketplace. The old world revolved around on-premise, costly upkeep, licensed infrastructures, and the inability to adapt to changing business models quickly enough to be effective. IT was constrained by this model, and as a result, the business was constrained in being able to quickly deliver results to the organization. Services like Amazon Redshift, EMR, and the other AWS services David mentioned enable all users in the business to build agile analytics infrastructures to keep up with constantly changing market conditions. So we typically see three paths that customers take to cloud data warehousing and analytics. Customers can choose to extend their existing infrastructure to meet new business needs by starting up a data warehouse in the cloud. They may choose this option to address a variety of different data formats not handled with traditional on-premise EDWs, but also because they are easy to provision, manage, and maintain. Customers may want to migrate their existing data warehouses to a cloud warehouse, though, like Redshift, because it's cheaper, easier to scale, and set up without storage constraints. So when customers typically take this approach, they implement a hybrid type of approach where they will continue to operate their existing data warehouses on-prem while they gradually shift and migrate their existing workloads and data to the new cloud data warehouse before shutting the original on-premise data warehouse down. And then lastly, there is born in the cloud, where customers don't have an existing data warehouse. They're looking for an elastic approach, and a cloud data warehouse is the way to go. So now let's hear from a story from Ryan Frazier, the Director of Systems Engineering Operations at HBX, who took the third approach and built out a born-in-the-cloud analytics infrastructure using Amazon and Informatica together. Ryan?
Great. Well, thanks a lot, Andrew and David there for the introduction, and thanks to everyone who's here attending. I'm really excited today to be telling the story about HBX, which is the Digital Education Initiative of the Harvard Business School. So we've got a lot of exciting things that we've done, both in terms of kind of building out our initiative as well as the technology that lives behind it. So I'm responsible for a couple different areas within HBX. So our DevOps team, which runs a lot of our Amazon platform, so kind of all the EC2 and other types of things. AV engineering for our virtual classroom, which we'll get a peek at in a minute. And sort of most relevant here for today's discussion is the data management work. So those are kind of the main areas that I'm responsible for here at HBX. And I really encourage people to go out and learn more about HBX and some of the things that we offer. You can find that at that hbx.hbs.edu, and certainly if you have questions or follow-on, can connect with me on Twitter there. So, all right, so a little bit kind of as we go through this today, we'll be looking, kind of give you an introduction to HBX, talk more in detail about sort of why we wanted to start our data management initiative, more of the technical part around the architecture and implementation, and a bit on sort of challenges and reflections on our experiences as we've gone on this journey into the cloud and through our data management work here. about sort of HBX and this vision of reimagining digital education that happened at Harvard Business School. As kind of would randomly happen, today is actually the 366th commencement for Harvard University. And so as I was walking into work this morning, I'm kind of going through Harvard Square, and it's full of all sorts of people in regalia, and it's very exciting, and there's big crowds and lots of parents and families and the students. But when you step back and look at it, sort of, despite the big crowds that I see here today, there's about 7,000 people receiving degrees, about 930 people receiving degrees from the Harvard Business School. And while that's a lot of people in one way to think about it, when you look at things globally, there's a huge audience there that won't have that chance to sort of show up here on campus and benefit from the experiences and the great knowledge and the incredible teaching that lives here at Harvard. And so this becomes really one of the key questions in higher education of how do we move sort of all of the great things that have been built here on campuses over hundreds of years kind of beyond the campus grounds. And I think for institutions like Harvard and all institutions in general, sort of, how do we do that in a way that's true to our standards and that really is sort of upholding kind of all that we've invested and sort of done to kind of create what we have here on campus. And I think for the business school, it was a particular question and a particular challenge is how do we do this in a way which is true to the sort of deeply ingrained teaching methods that we have here. So if anyone's ever done anything about the case-based methods, that was really born here at the business school, and it's really about kind of interactive discussions that happen in classrooms around real-world experiences and cases. So in about 2012, 2013, the business school decided that they wanted to look at kind of how do we take this experience online. And so out of that was created HBX and tasked with reimagining business education for the digital age. And so kind of in reimagining things, it was really going beyond wanting to do just sort of lecture capture and publishing slides that you see a lot of platforms. That just doesn't work from the classes that we run at the business school, but also we didn't feel that that was really the most effective way. And so kind of how do we create a highly produced, content-driven experiencing using technologies so that we can build these engaging exercises online and kind of create some of that peer interaction model that we have. And so that's kind of that active social and case-based method that we had. And really sort of at the end of the day, this is about sort of how do we take the mission of the business school, which is to educate leaders who make a difference in the world wherever they are, and extend it kind of to the global marketplace. And sort of what we've been doing now is sort of building out this expanding portfolio of courses targeting people who are pre-MBAs, a lot of mid-career professionals, and we actually see probably for this audience more relevant, a lot of people who are technology trained or in entrepreneurial startup environments who haven't had a lot of business experiences and are really kind of learning to grow their education, but don't necessarily have the time or the resources to kind of show up on campus for an MBA, but are looking for something that's really a quality experience there. So out of this came two platforms that we built. So the first that we built was our course platform. It's similar to other online education offerings that you'd see Coursera and edX, but it's a much richer experience. We really spent a huge amount of time kind of building out and sort of carefully designing sort of all of the experiences that are in the platform. While kind of a lot of the other education things talk about MOOCs, kind of the emphasis on the massive is the M there in massive online open education. We really didn't want a massive experience, and so we run people through in a cohort-based model where sort of we try to pair people together in groups of a couple of hundred so that they can get some sort of peer experiences and travel through courses together, although we can still scale by running multiple cohorts simultaneously. And this allows kind of that building of engagement and bonds. And so up to date, we've had about 17,000 participants take our courses since that launch in 2014. Our other platform is the HBX Live platform. And this is really kind of very exciting, and this probably captured your eye as you went through some of the, saw the marketing material on this. This is the picture from that. This is a global classroom that we created at WGBH Television Studios here in Boston, that we're trying to really create sort of the experience of being in a classroom, that on-campus experience, but without actually having to be here on campus. This kind of required a huge bespoke mix of technology in order to build it out. We have digital signage software, unified communication platforms. There's a custom web application which the students log into to view the experience. There's broadcast grade AV equipment, and all in all, kind of in addition to this kind of big curved LED screen for the 60 participants to dial into, there's about 10 racks of equipment in a data center up above this that enables kind of this live experience to occur just like you're here in the classroom. And you'll see that's Bharat Anand, who's our faculty lead for HBX, as he was presenting a case there. We've had about 3,000 participants to date since we launched this in the fall of 2015. So when we looked at this kind of, you know, sort of a lot of what was done there with those two platforms was initially launched as an experiment to see, can we even kind of deliver the type of education that we're interested in an online fashion? And sort of after, you know, after a while, it was very clear that this was a successful endeavor. We were getting great feedback from people who were participants, really engaged people. We actually host an event on campus here for past participants, and we had over 400 people show up, and half of them were more than 1,000 miles away, some coming from Europe, India, Australia, which is really incredible for what's essentially an online course experience. So it was clear that this was successful, but kind of as we were going through this, there were lots of questions people started to ask as they were trying to evaluate this and understand it. You know, how do people engage with the material? Who is successful in this environment? Who are we reaching, and sort of how should we market to them? And then kind of how do we operate efficiently so we can reach scale and try to deliver this experience to as many people as possible? And, you know, obviously, as you step back and look at this, these are all questions of data. And when we started this, trying to answer those questions was an extremely laborious and challenging process. People had to kind of log into a bunch of different systems in order to extract the data. There was a lot of work in Python, lots of kind of deep SQL coding, a lot of trying to kind of figure out how do we piece together data from lots of different data sources to get that viewpoint. And so kind of we were highly constrained in being able to deliver insights because there were only a few people who could actually work with the data and understand how to use it, manipulate, and get that information back to everyone who was doing that. So in 2015, so about a year after that initial launch, there's a decision to launch a data initiative, and really kind of wrapped into a larger goal of trying to build a data-driven culture for HBX. So there's lots of reasons why to create a data-driven culture, but I think we kind of really took a step back and thought about this from the business perspective of who are our customers and kind of what are we trying to achieve and what we can do with this. And this really comes down to kind of, you know, obviously our core constituency of the learners, the students, the participants, and our platforms, and making sure that we understand and can enhance their outcomes. For staff, it's all about really how do we improve their efficiency and effectiveness, and as we scale and grow, that becomes increasingly important. For faculty, there's lots of questions about the pedagogy. You know, how do I use this new medium in order to teach? What's most effective? What's resonating with learners? And kind of what can we learn about learning itself through this massive amounts of data that we're able to collect? So those are all very compelling and interesting questions. And then underlying all of this is really this notion of, you know, fostering innovation and achieving continuous improvement. And I think that sort of goes across all of those different constituencies and areas that we have. So from a program perspective, as we put this together, there were really sort of, you know, some very pragmatic things that we needed to do in order to achieve this larger data-driven culture objective. So obviously we needed to build out technical foundations. We needed to make sure that we could address and serve the needs of our users and focus on them, both kind of for standard types of reportings and dashboards, as well as self-service approaches. And above all, I think kind of, one of the key elements of any data management initiative is this focus on quality. If the data is not good, if people can't trust it, you're never going to get that value out of it, and you'll have made a lot of investments that never kind of return what you're expecting to the organization. For us, and I think this is an important thing to think about for everyone out there as you're looking at your data management initiatives, is it's more than about the technology. The technology is fun, it's really exciting and cool, as we'll see from Andrew and David, but there's a lot more about this than just that technology. In order to be successful, you need to kind of build on those things. And I think it's important to look at your own organizations and think about, what competencies do you have, kind of what cultural elements can you draw on to help build your initiative and create the momentum and serve the needs and generate the value that you're looking for. And I think, for us, these were some of the things that we had. We had a really strong partner. Mindtree is an offshore that we use to help develop our platform and do QA and a number of support services, and they've helped us build out this platform. And so that was a great thing that we were able to leverage. We had really engaged business groups. We're a very tight, fairly small organization here, so it was easy to work with the business teams and on that program governance. Obviously, as a learning institution ourselves, as someplace that's focused on delivering education, our own staff, and here kind of that education element is very important. And so people are very excited to learn more about sort of data and data initiatives and how they should be thinking about data. And really kind of our culture of experimentation sort of drove us to kind of be pushing the edges as well. And I think kind of as you look at all of these things and you think about kind of your roles as technical leaders, I think that's kind of interesting because it helps you think about sort of the evolution of technical leadership as well. And that kind of, as you get these cloud-based services, you can really think about more about sort of non-technical aspects such as of these and sort of rebalance, if you will, your personal time portfolio and sort of kind of think about where you add the most value. And I think that's one of the key things about the cloud and the enablers there is sort of how fast, how speed, how kind of the value from a cost perspective allows you to really build on these other things and think about kind of what it means to be a technical leader. So moving a bit beyond the general notions here of kind of the background and the program, we can move into sort of the more technical aspects here and sort of get a bit into the meat of things. And so when we were looking at this, obviously kind of the first part of any project is really thinking about the tools and what you're going to build your infrastructure on. And there are a couple of key fundamental things that we were looking for in order to achieve this. So first of all, we wanted speed. We're a fast moving, we're still kind of essentially a startup. We wanted speed in contracting, so that's kind of where could we leverage existing relationships. We wanted speed in setup and implementation, and we wanted speed in terms of our ability to do things kind of, for ongoing development, use, and innovation. We wanted to align things with kind of investments and sort of what our existing technology stack was, which was Amazon Web Services for our platform. We had tooling around operations and monitoring that we could help tie into, and sort of the business school and the university also had sort of lots of investments in both Amazon Web Services and Informatica that sort of aligned well with what we were trying to achieve. And finally, sort of looking at value. So, where can we get price performance? The Redshift is an amazing sort of solution there. If I look across the entire portfolio of Amazon services that we use, Redshift is actually only 3% of our spend. So that's a really amazing thing to kind of be able to deliver a data warehouse at that level of investment. And I think the other thing is the ease of use. And I think when we look at Informatica, the ability to kind of easily build up things, sort of the cost savings from labor and able to kind of quickly and rapidly quickly build up our ETL processes, as well as the extensibility that it offers to sort of add in new connectors so that we can look to sort of additional data stores. All of these things were really valuable to us, and looking at that. So when we take all of those things together, it clearly spoke to us and sort of, you know, said cloud, and those really drove our choices for Amazon Redshift for the data warehouse, for Informatica for the ETL processes, and for Tableau for reporting and analytics. We have another component with Snowflake, which I'll talk about a little bit in a minute here as well. From a numbers perspective here, I thought I'd just kind of put this up here. This is reasonably big. I'm under no delusion that that this would be called big data by any means, but I think it gives you a little sense of kind of the scale that we operate at. But I think kind of for us, in some ways, the challenges were less about sort of the volume of data and a little bit more around sort of kind of how that data was organized and sort of the environments that it was in. And I think, as you can see, there's a lot of Mongo data in there, which is an interesting challenge. Kind of the other part, you can see here, this course platform version A and version B. We had an interesting release approach when we started, which was to sort of build each new release, kind of upgrade to the course platform that had sort of new teaching elements, new features, new things on its own new production platform. Because all of our courses are no more than about 12 to 14 weeks, we could run through a set of cohorts, get them through that, keep that production environment very stable, launch new features and new cohorts on a new platform, and then kind of as people aged out of their courses, we'd sort of drop the old ones off the back end. This helped us move very fast, but from a reporting perspective, this becomes a big challenge because now we have multiple production platforms running simultaneously, and that was really one of the drivers of trying to consolidate everything into Redshift. So we had kind of these running platform copies. We also had historical data from kind of old versions of our course platform, as well as our administrative systems. And then sort of all of that we would bring together using Informatica, which has kind of these two components where there's the Informatica Cloud Services, where we store all the job definitions, kind of the mappings and things like that. And then the secure agent on premise, which is actually what sort of handles all the connections to the data itself and the transit of that. So that offers a lot of sort of security when we look at the cloud architecture of that. And then that sort of moves on for Tableau, where we have our reporting. Today, as everyone loves a big complicated diagram like this, kind of you can see in the upper left sort of that core is still the same, but what we've added are sort of, we've expanded the number of data sources that we're including. So we have Salesforce now, and within the next month or so, we'll be adding sort of additional data from ServiceNow for our end user ticketing, from Google Analytics for web traffic, and from HubSpot for our marketing campaigns. We've also been able to add in sort of information from HBX Live, which is kind of local data center for some particular reasons of how that is architected. We're using Splunk to currently feed that in, but that'll eventually shift to sort of more traditional database through Informatica. And then we had a number of challenges with how we handled Mongo data that caused us to add in Snowflake as essentially our JSON data lake, where we're able to do some granular normalization of our complex Mongo data. We have a lot of polymorphic, sort of strange structured data that's hard to kind of transform in a lot of the traditional ways. And so this allows us to do some intermediate transformations before we kind of connect that, again using Informatica, back into our relational tables in Redshift for reporting off of Tableau. And then we're doing a couple of things around streaming data with both Firehose and, as I mentioned, Splunk as we look at that. So kind of thinking a little bit, reflecting on that. That's not actually me, that's my one of my colleagues here at another presentation where we were talking about our implementation. But sort of returning back to sort of the technical objectives that we set out to, you can see that sort of within the 2 years since that we've launched this initiative, we've had significant progress, both in terms of building up that core system, developing a whole bunch of reports that we can deliver to our business users. We've got great penetration within our business users and the staff here in terms of actually using all of these reports that we're building, and sort of have continued to focus on the QA side of things and make sure that the quality is there. thinking about kind of, our implementation and where we've come, I think kind of, the cloud services are certainly something that has been important for us, and it lets us focus on what creates value now for us. So we can move fast, we can adopt quickly, we can pivot rapidly as needed, and then we have we're building upon these larger platforms and ecosystems of both Amazon and Informatica that helps us further accelerate. So we get plugins, we get new features, we have marketplaces, and so there's lots of things that allows us to kind of quickly look at what are our current needs and how do we sort of get to them fast. And I think that's just a fantastic approach for us. This kind of lets us focus on sort of the specific needs and challenges that we have, and sort of for us it happened to be semi-structured data within the Mongo databases. For you it might be something else, but I think that's kind of where kind of looking at and kind of then really digging into those key problems. And I think kind of, whether it's this particular cast of things of semi-structured data or other problems, I think it's important to remember this market moves incredibly fast, and so the decisions that you make today may not be the same decisions that you make in 6 months. And I think there's two cautionary tales there. Is one, don't spend too long thinking about kind of what you want to do today. Find out what's works, do it quickly, and if it's kind of not working, go ahead and wait 6 months, because there may be a solution then. And then the other thing is sort of, as you're doing this, make sure to revisit your decisions frequently, because I think that's very important for your agility to be able to kind of, always looking at how can you make things better, how can you improve it, how can you take advantage of new services and features, and how do you build upon that. And I think kind of all of the things that you saw David talk about, kind of all the things there that are coming out with Redshift, these are things that just, we're not used to having that type of speed in these types of services, and you've got to learn and adjust with how you can take advantage of that. And then finally, I do kind of want to highlight again, I mentioned this a couple times around sort of QA testing, and really I think for data management, quality is job one, to steal that. And I think it is both kind of data quality in the notion of the reality of it, but also the perception. Even if your data is perfect, if for some reason your user base isn't certain, they're going to stay away from it, they're going to use alternate sources, and even if those alternate sources are worse, if for some reason they are comfortable with them, you're not going to get the value. And I think you can see obviously a lot of the risk there. So reward your customers for finding problems in all of this. And then if we look kind of forward at sort of, kind of out of all of this, we've gained a huge amount from a business perspective, and sort of, tying it back to those needs of staff, faculty, and students, we can see all of the things that we've achieved here. And I think we've really been able to innovate and get to a lot of continuous improvement on our application processes. We've been able to look at some of our course structures, and I'm starting to hear around the organization more things like, how can we test this, and here's what the data tells us when there's presentations going on, and what can we do to get additional data. So all of these questions are really great and exciting to hear and speak to that building of sort of that data-driven culture. A couple things kind of on our horizon and roadmap here. I won't go into details here, but I think kind of all of them are about, kind of what are the current needs that we face, and sort of what are the needs of our users broadly. And I think as we look at this, it's also kind of, critical and important that I just don't look at the technology, we just don't think about some of these things, but we tie back to that underpinning mission that we have of, educating leaders who make a difference in the world wherever they are, and thinking about how do we use data and our platforms in order to make that happen. And I think kind of that's really the value of the digital technologies. And while it's kind of exciting, like I said this morning, to be in the square, seeing all the people in their academic regalia, the underlying goal here is not just to bring people to Harvard, but to really help Harvard reach the world. And I think kind of, the tools that we have here are really doing a fantastic job of helping us achieve that. So that's really kind of what we have to say here. I think we'll have time for questions at the end, but I wanted to hand it over now to Andrew to keep going on the next part and learn a little bit more about Informatica.
Thank you, Ryan. That was an amazing story and really interesting to hear. So now let's talk about how you can use Informatica solutions for AWS and help you build out your cloud analytics architecture like Ryan and HBX did. So David mentioned earlier, Redshift is a powerful petabyte scale data warehouse. but loading data and updating records can be cumbersome and requires manual coding and multiple steps with code that needs to be maintained for constantly changing source APIs and optimization. But what if there's an easier way? With Informatica, you can easily load data in 3 simple steps. You simply choose your type of operation, map your fields, or create a new target on the fly if you want to, include a new target table, and then you set your tasks to run on a repeatable basis. With Informatica Cloud, customers can build out a self-service, governed analytics infrastructure in a multi-tenant SaaS-based environment. Users can easily source data from any data source, whether on-prem or cloud, develop their integrations in an easy-to-use drag-and-drop mapping designer or wizard-like approach, which can be used by multiple users in the organization from IT to the business. And then they can set their jobs to run and scale with their particular business needs. So I say this is a governed self-service because IT can manage the Informatica Cloud application, while citizen integrators and end business users can reuse and build out their analytics environments in a non-siloed approach. And with Informatica Cloud, you can connect to any data source from anywhere to fuel your company's analytics needs. So the Informatica Redshift connector is designed for high-performance scalability, but the connector supports both native connectivity using Redshift prescribed guidelines of loading data through S3 and into Redshift staging tables in bulk multi-part upload. But it also supports ELT, or extracting, loading, and transferring, so including SQL pushdown for source and target Redshift table pushdown when the data is moving from the staging to analytics tables within the same cluster. So the native connector allows for Informatica, the native Redshift connector from Informatica allows you to ingest data from multiple different data sources in bulk, and really allows users to partition out source rows, then compress each set of data in parallel locally before transferring in parallel the compressed files to S3. From there, the connector automatically initiates copy commands, again in parallel, to each slice in the Redshift target table. All this is handled by the connector, and all you have to do is specify the S3 bucket and the local staging directory, as well as a few other optimization options. But all this work is performed by the connector. No coding is necessary. So here's a deeper look at how the connector in bulk ingests from the source APIs, batches reads, and then performs key range partitioning before loading data into Redshift, further leveraging the power of Amazon Redshift in order to improve mass data transfer. So to sum it up, the Informatica Redshift connector is the most robust, comprehensive, performant, and secure Redshift connector available. Whether you need capabilities for partitioning, SQL pushdown, S3 server and client-side encryption, or the ability to analyze and vacuum target tables, we've got your back. And Informatica is more than just an ETL company. We provide enterprise-ready data management products for any size company. And here's a list of those products certified for use on AWS, as well as a list of solutions available on the AWS Marketplace, either in a one-click deployable model or a managed cloud service like Informatica Cloud. So if you want to try some of these solutions like Informatica Cloud, you can go out to the AWS Marketplace and search for Informatica. Here you'll find both contract and pay-as-you-go offerings to fit your use case, as well as subscription-based pricing. And for PowerCenter users out there, if you're interested in deploying PowerCenter into your AWS environment, we have both quick starts as well as marketplace listings available in a fully integrated one-click deployment. So in summary, Informatica's iPaaS solution is robust and really the most comprehensive solution on the market for loading data in and out of AWS. In fact, over 7,000 customers trust Informatica Cloud to load over 1 trillion records per month. And here's a short list of some of those customers, including Amazon, which relies on Informatica to fuel their marketing analytics environment. And with the Informatica Intelligent Platform, we provide a fully integrated data management suite that enables companies to do everything from mastering their data on-prem in the cloud, as well as big data, to data cataloging, and to enterprise-scale governed self-service integration. So really, we cover the full breadth of solutions across the data management platform. And of course, as you look, and you can see by the latest analyst industry reports, Informatica leads the market in all 6 Magic Quadrants for data management. So if you'd like to learn more, we'll be providing you with additional information, including deep dive records architectures, especially around cloud analytics, similar to what Ryan was implemented at HBX, as well as how you can get started today using Informatica and Amazon Redshift together. So we really appreciate this, and want to thank you here for the opportunity to speak to you guys today. At this time, I'm going to turn it over to David, who's going to address the Q&A. David?
Great, thanks, Andrew, and thanks, Ryan, too. Great presentation, guys. Some interesting stuff. Generated a lot of interest from the audience. So I've got a couple of questions that I wanted to bring to you guys' attention, and this one's for Ryan. And a great question. He asks, what did you use Snowflake for? Like, how does it add to like the Redshift architecture? Like what was the decision point for using both?
Yeah, so you know, kind of, I think Snowflake has been a lot of times kind of gets positioned around sort of the features of scale that they have, but as you can tell, kind of our data needs weren't really about that. What happened to really appeal to us there was the way that it's able to handle JSON data, in that sort of it creates a column, kind of a new column structure that they call a variant, that allowed us to sort of load in all of our JSON data. And actually, I don't know if we still have some of those slides that were in the back. I actually thought this might be a question. So I'm not sure if they're still in the presentation or not. But basically, within our course platform, what happens is we have sort of what we call teaching elements. So this is kind of something that would show up on the page of a user, that's an interactive element in a course. So the simple ones are, of course, like, you know, straight text HTML types of things or a video. But we have lots of other things that are a question and question answer set. They might be a poll. We have things that are sort of graphical sliders that people can use, down to sort of actually embedded Excel spreadsheets that people are able to kind of set up chart of accounts and sort of balance equations for accounting purposes. Each of these are stored as JSON documents within our Mongo database collections, and there's probably 75 different types of these. And so what we end up with is kind of deeply nested within our JSON structures are all these very polymorphic structures that don't resemble each other in any sort of way whatsoever. Most of the current kind of, when we were looking at this, and this is why I say, you know, always check, because there's more features, and I know Informatica has added kind of more support for JSON structure and XML types of things, and same with Redshift. But at the time, sort of the structures that handle JSON data, what they're really good at is they can look at sort of hierarchical data document structures, and they can flatten them. And the way they do that is they do sampling across the data and then come up with the right model, and then they flatten it out. Well, given sort of the complexities within the data, those models would fail, and so kind of it couldn't properly handle them, and it couldn't flatten them out into sort of structures that we could move into our relational stores there. So what Snowflake allowed us to do is basically load the raw JSON into there, and so I'm calling it my JSON data lake, I guess. And then from there, what you can do is kind of essentially we would run queries on that, so you can do kind of specific traversal kind of dot notation queries into that data, and so we can actually sort of kind of run a query, create a view, run another query, create a subview, and basically traverse down those document structures until we get a sort of a particular element in a particular relational format that we are then able to sort of ETL out into our Redshift environment. So this unlocks kind of a huge amount of data that we had that was really hard to get to in this relational way. And I think for a while we were feeling that we were going to have to sort of, did we have to sort of, go slap the hands of our developers and tell them they needed to sort of structure things, in a particular way in order to handle our reporting needs, which we didn't want to do. And so this allowed us to kind of maintain the flexibility of the NoSQL, semi-structured database that Mongo offers us, as well as kind of get the benefit at the other end of being able to run all these relational queries on it and create structured reports and joins across other types of data on the analytical and sort of reporting side of things. So that's kind of how we used it, which is a little bit of a different use case, and kind of within that mechanism is still, sort of Redshift as the ultimate endpoint, and Informatica is sort of the one of the mechanisms we feed that data from one point to the other.
Snowflake's a great product, so I'd love to hear you guys using it in a neat neat way. Another question that we had, what was your frequency of data load into Redshift? Are you batching, micro batching? Is it semi-continuous?
Yeah, so kind of most of what we're doing is really batch data loads. So for some of our smaller collections of data, we actually do a full trunk and load of those. For our Mongo data collections and some other areas, we're kind of doing incremental data loads on those, but they're currently mostly daily batch jobs. If you looked at that architecture diagram, kind of one of the things that we're experimenting with is looking at Kinesis Firehose to load up things in a continuous streaming fashion into Redshift. Kind of the main use case there right now is we have a lot of what's essentially clickstream data that we're pushing from our operational platform into a Mongo database collection, and then we do these ETL processes. It's actually sort of, it doesn't suffer from quite as much complexity as the other data I was talking about, but really it's sort of, now we've got sort of a really big Mongo collection, that we have to run operationally, and then we also have to kind of pump that through to the ETL. We don't use any of that data sort of within the platform itself, kind of from a transactional purpose. So kind of what we're experimenting with now is Firehose for some new type of clickstream data that we're collecting, so that we can just kind of push that directly into Redshift that way. So that's kind of exciting, and we might kind of move to more of that model for that type of data for certain. And I think kind of I think the eventual goal is obviously sort of the more real time that you can make all of this, the better. But I like to sort of start simple, get what we need, and kind of incrementally improve on all those things.
Yeah, it's like Zeno's paradox, right? Real time is, really real, but even shortening those cycles improves business outcomes. So you kind of talked about the future. I do have a question from the audience. Do you feel like your architecture is ready to leverage Amazon's machine learning solution the way it is? Or are there kind of additional prerequisites if you feel like you need to get there?
Yeah, so kind of machine learning is definitely a topic that's on our mind, and we've thought about it, things for looking at our support cases, for looking at our admissions processes, looking at grading or evaluation within the course platform itself. So we have a lot of things that we're interested in. I'll be honest, we haven't really gotten to the point of thinking about sort of in what state is our architecture to be able to further leverage Amazon's machine learning service, and that's really kind of more sort of business and priority decisions at this point, in that kind of, as you can see, we still have kind of data sources that we're trying to load in, and so there's a lot of things that I want to make sure that we have all of our bases covered, that we've got all the data that we need in the system, that the data quality is good, that we have things structured to make it easy to use, so that then we can sort of kind of move on to machine learning. We'll probably be doing a POC of some sort in the next year that'll help us understand some of those architectural questions, but we haven't really looked at kind of exactly how that would plug in at that level.
Okay, great. Thanks for that, Ryan. I'm going to let you get a drink of water. I have a question for Andrew. And I got a couple of forms of this question, but what's the difference between Informatica hosted, in a customer's own AWS VPC versus the Informatica on cloud or the iPaaS, or there's a couple of ways people approach this, but what's kind of the difference there?
Yeah, that's a great question, David. And really what we look at it is, we have a lot of legacy customers. We have a kind of a gold standard ETL engine called PowerCenter, and that's been around in the market for the last 20 or so years. Informatica Cloud is a newer iPaaS solution that we came out with about 10 years ago. But it's very so it obviously has a lot of market share, and it's been used regularly. Like I said, I showed you kind of the stats on that earlier. But the difference is that Informatica Cloud is a multi-tenant environment where you can host the actual SaaS-based environment is hosted on Amazon, but what we have is that secure agent, and that secure agent can be installed on your within Amazon, on an EC2 instance within your VPC, but it can also be installed on premise. It's all dependent upon where your data is. So, for instance, if you're trying to move data from source, an on-premise source, like maybe a Teradata or some or an Oracle data source on premise, and you're moving data into Redshift, it probably behooves you to put that secure agent and install it behind your company's firewall. And you can see how Ryan kind of set his architecture up, where they actually installed it within Amazon, because they were doing a born in the cloud type of architecture, like I talked about before, and it made more sense to have the agent there because that's where you're closest to the data, and then you can access all of those different SaaS apps, and it seemed to make a lot more sense to actually ingest the data that way. So that's kind of the difference between having that. But like I said, you can install Power Center onto AWS if that's where you'd like to run. But of course, Informatica Cloud, like I said, it's a hosted multi-tenant environment, and of course you can install those secure agents to securely access and transfer your data in any location you want.
Great, thanks for that, Andrew. I think we may have time for one more question. So this one's for Ryan and maybe for me too. Were you guys seeing any impacts on performance from vacuuming in Redshift?
I don't think we actually are doing as much vacuuming as we need to, and I think kind of also the way that we're using it, we're not. If there were performance impacts, we're probably not likely to encounter it. We're not sort of taxing that environment all that much. I think kind of for vacuuming, most things for us is kind of making sure that we do it frequently enough. So it's great to see those auto vacuuming things come up there to kind of clean up space and not have to grow the cluster out.
Yeah,
so that's what I know. I'll leave that the better answer to you there.
Well, it's an answer. I don't know if it's better. So vacuuming is all about really kind of it boils down to two things. One is removing blank rows, right? You have empty space. You want to kind of scrunch the data together so that it can be written sequentially on disk. The other piece is that's when you get your sorts done too. So if you're using any sort of time series data, you're definitely going to want to vacuum regularly. So think of it as a cleanup task, or if you're in an old SQL DBA, maybe like update statistics, those sorts of things. Just kind of makes it run better. And you shouldn't see a heavy impact from vacuuming. We've done quite a bit of work on that. So if you are seeing something that's slow times, please feel free to reach out to AWS support because it shouldn't be a deal breaker. So we are at the top of the hour. I want to thank everybody who attended the webinar today. And like I said, you'll get a link to the slides and the recording in the near future. Big thanks to Andrew. Huge thanks to Ryan. Cool stuff at HBX. And thank you so much and have a great rest of your day.
Yeah, thanks, everyone.
Thank you. Appreciate it.